All right, welcome to today's lecture. Today we're going to continue to discuss file processing. So last week's lecture we covered reading from a file, and today we're going to cover writing to a file or writing to a file stream. So you'll find that this will be a very short lecture, and it will in fact be a short lecture, not like all the other times that I promised they'll be short and then end up talking for a long time. We'll jump right into it then. What you're going to see is this is going to be very similar to reading to a file. In fact, there's only one thing that we have to do different, and that is we need to print to the stream. We have to send the data that we want to print to a file, put in a file, to that same stream that we open with our file pointer. So with that, there'll just be one function that we're going to look at, and that's fprintf. And like those similar functions that we had when looking at reading from a file, it's going to behave very similar to printf, except that we're going to have one additional argument, which will be our file stream. So you'll see that even in its use, even though it's a new function, the concept and how we use it is going to be very similar. There's one other catch though with opening file streams in order to write to that stream, and that is that you need to make sure that you open it in the right mode. So when we use the fopen function, we have two arguments that we send to that function, and one is the location of the file that we want to open, and the other is the mode that we want to open it in. So we want to make sure that if you want to write to the file, that you open it in the mode that you want to correctly write to. There are different modes. There's modes that are going to open up that stream, clear the contents of the file, and then allow you to write to it. There's modes that are going to allow you to open that stream and then append to the file, and that's probably the case that you're going to want to append. For the lab, that is definitely the case. You don't want to open that file and clear the contents. If you do, you can always download that same file again from D2L, so it's not a big deal, but we do want to append. So just make sure that you're familiar, you're comfortable with whatever mode you're looking at using, and we'll take a look at that in the sample code here. Here's our prototype for fprintf. Okay, you can see that there's this additional argument, this very first argument, and it's our file stream. Otherwise, it has a variable list of arguments. We have our format specifiers, and then we have the values that we want to print. So we're going to use it just like printf, except this first argument. Instead of printing to standard out, we're going to tell it what stream we want to print to, and that's going to be the stream associated with a file pointer for the file that we're after. Okay, so we'll see how that works in code. As far as that, this will be our practice. I'll get this created in a Word doc and upload it, so you can go ahead and do that if you're interested, if you think that would help. As always, send me an email, send me the practice code, upload it, whatever way works the best, and I'd be more than happy to take a look at that and give you some feedback. So get out of these slides then, and we'll move into the code itself. Before we get into writing, let's take a look at our reading program. Okay, just as a refresher. So file.io.c, this is what we have uploaded in D2L, so this is available for you to look at. And what this program does is it simply reads a space-separated file and displays the contents. Okay, so I guess let's back up even one further and let's take a look at that file real quick. So I called it students.dat. Keep in mind that C doesn't impose any file structure. As far as C is concerned, it's just a stream of bytes. So it's up to us to correctly define the structure of the file that we want, and then to enforce that structure, the constraints of that structure in our program. What does that mean? Well, it means things like these columns. They need to be the same for every record. Okay, if I say that this first column is name, the second column is major, and the third column is student ID, then I need to remain consistent with that file structure in my program and in the files themselves. If all of a sudden I change this, the order, then my program probably isn't going to recognize that. And so it's not going to generate the outputs or work the process, whatever the logic of your program is set to do. It's not going to probably work correctly. So, once we create a structure for our files, we need to stick with it. Another thing is in how we separate the data. In the case of this program, we're using spaces, right? So that's why you don't see, Tom Halverson as in that format, because I'm separating this file with spaces. We're just keeping things simple. Okay, so spaces delineate the file and the data within that file, or I guess more specifically, the data within each record. Oftentimes you'll see comma, CSV. If you create a file and you separate the values with commas, that works until you actually need a comma in that data. That's not what we're doing here. You can do tab separated. That works as well. So it's just up to you. As far as our C program goes, it doesn't care. It's up to us to make sure that we identify that structure and then enforce it in our code. So with this example, again, space separated, right? And then in our program that's going to read the contents, what I did was I created a struct that represents that data. Okay, and I did it in the same order as well. So we have name, we have a major, and then we have this unsigned int for the student ID. Inside the main program then, all this program is going to do is it's going to try to open the stream to that file, read each record in that file, print it off to our screen, and then stop. So in order to do that, we talked about the file pointer. So we declare that here, set it equal to null. I do anyway, I initialize it. I create a struct to store the contents of the file, so I'm going to use that same variable, that struct variable, over and over again with each record that I read. Then for this condition, keep in mind or think back to when we talked about fopen. Fopen allows us or attempts to open a stream. If it cannot find that stream, if it cannot open that stream for us to assign to our pointer, then it's going to return null. So what we can do then is in this condition, in this if statement, we can have an assignment operation. We can wrap that in parentheses. Okay, so we did that here and here, and then we take the result of that assignment and we compare it. Now we're doing a double equal, so we're doing a comparison. We compare that equal to the null value. Okay, so if we can't open a stream, our program can't proceed. So if it's equal to null, that means we did not open the file. That means we should probably stop. In this case, because this program only has this one branch, there's this if branch and then there's the else branch. And if we go down a little bit further, the program terminates. If we enter the if branch, we won't go down the else branch, and our program will terminate, so it just won't run. If we are, and then keep in mind here, okay, so here's our fopen, here's those two arguments we talked about earlier. There's the file that we want to open, and then there's the mode that we want to open it. So ours read only. And in a program that's only reading the contents of a file and displaying them out, that's a good thing. That's a good mode to open it in, as a read-only mode. Okay, this is going to look for that file in the same directory that you're running it. Okay, so wherever you compile your program, wherever you run that, it's going to look in that same directory for this file. So as long as you put the two together, that's fine. You don't have to, but for us, for the class, it's just as easy, so that's where you can do it. There are the relative and absolute path. Okay, so if we're on a Linux system, we could do something like that first / is the root of the file system, and we could define a file system path, a full path, an absolute path like that. We could do something relative, and we could use the ... and go back a directory, or maybe we have a file in that same folder, a folder in that folder that's called files, and it's in that directory. So I'm not worried about anyone doing that. Feel free to if you want to add extra organization to your program and your file structure, but it's no big deal. All right, so let's assume then that we open up the file and we have a stream to it. So our CF pointer is now assigned the memory address or the return result from our fopen call. We go down the else branch, and then all we have to do is here I print off just a header for the output, okay, and then we use fscanf. Okay, so we use scanf very similar to how we use fscanf very similar to how we use scanf. The only difference, much like fprintf that we're going to look at here in just a minute, we have a first argument, and it's our file. It's our file pointer. Okay, use the same format specifiers. This is the format that we're looking for that data to be in the file itself for each record. Okay, a string, and then a numeric, and that's true. If we go back and look at the file, we have a string, and then a numeric. And then here are the variables that we want to store those values in. Okay, so we're using that structure. We have name, we have major, and then we have student ID. Okay, then inside here we print, and we just keep looping. Okay, the condition of that while loop is our fscanf. And if we scroll all the way over, you can see that while fscanf is not equal to EOF. Okay, EOF represents the end of file. That's a symbolic constant. If you printed off the value of that symbolic constant, you'd see it's equal to -1. And we're comparing it equal to -1. fscanf has a return type of integer, and what it does is it returns an integer value representing the number of matches. Okay, so for each record that it reads out of the file, we should have a string, and a digit. So that means that it should match three pieces of data in that record, and fscanf should actually return, not only does it assign the values to these variables, but it'll actually return a numeric value 3. When it no longer finds anything to match in the file, it returns -1. And that's how we can use this function call with the comparison to EOF inside that loop. So as soon as it returns -1, that means it did not match any data in the file, and we know we've reached the end of the file. Okay. Here's some code commented out. Okay, that was just to discuss rewind. We don't need rewind for writing to the file. And then fclose. Okay, so just like when we free memory, when we're done with a file stream, we want to call fclose on it and release that stream. One other thing with fclose that you'll want to know, if you haven't come across it, or if I forgot to mention it in the last lecture, is it flushes the buffers. So sometimes what you'll see is you'll call fprintf. Oh, I'm sorry, I'm getting ahead of myself. We'll talk about that in just a second. So we're done reading the file. We'll call fclose. We're done with it. Okay, so that's all you need to know about as far as reading. Writing. Okay, so here's we're going to have two things we're going to look at. We're going to look at the program itself, and we're going to look at a file that we're going to write to. And you'll see here in just a second with my fopen call that I'm going to use a file called studentsv2.dat, and right now that file is empty. Okay, so very similar. I don't use a struct in this program because of the way it's structured. You don't really need one. I could have, okay, because I'm using the same variables here, so I could have declared one. I guess I got lazy, so whether you do or don't, it's not a big deal. Declare a file pointer. We try to open the stream. Okay, so the file exists. It's an empty file, but it exists. I use W as my mode. So all this logic here is exactly the same. If we are able to open the stream to that file, we'll go down this else branch, and we'll have just a little bit of output to make the program work. Okay, so one puts to say, this is the format I want you to type the data into. So I want you to type name, major, and student ID. What we're going to do is we're going to use the same format, the same file from the last program that we looked at. We're just going to write to it instead. So we're going to put the name, the major, and the student ID. I'm also going to ask them to enter at the end of file to end input. And that's just simply a key combination. So up until now, you've been doing Control-C. Control-C will just terminate your program. Control-D, at least on Linux, Control-D will send end of file. Okay, and that's how you'll see that that'll actually terminate the program. On Windows, I believe it's Control-Z, and I think Mac is Control-D as well. And then finally, I print off a question mark. And the only reason I do that, that's what the author does in the book, and it's also just a way to tell the user that you're ready to accept input. So anytime they see a question mark, that means that's an indication to them that the program is ready to accept input from them. Okay, we need to get the input from the user. So we use a scanf, very similar to what we've done in the past. So a string, and a numeric. So they'll type that information in. We'll store it in these variables, name, major, and student ID. And then we'll enter into a loop. So what this program will do is it'll allow them to enter in as many records as they need to. They'll hit Control-D to send the end of file to terminate the program. Okay, so here we can use, a little more effectively than in the last program, we can use the FEOF file function on the standard in stream, and as long as it does not detect that end of file, then we're going to keep looping. Okay, so after every iteration of this loop, we're going to check, did the end of file come in on the stream, on the standard in stream? That is, did the user hit Control-D? If they didn't, that means they typed in regular input, and we'll do another iteration. Okay, exclamation point, logical negation. So I assume we've talked about that in 150. It just makes the opposite. Okay, it just takes a true statement becomes false, a false statement becomes true. That's all it does. So while FEOF, when it sees the end of file, then it will return true. So while it's not true, we want to keep going. While it does not see the end of file, we're good to go. All right, here's our new function. All right, so we had a scanf here. We've gotten at least one set of input from the user. They're stored in the name array, the major array, and the student ID variable. So now we want to print those off. Okay, so fprintf, only difference. Okay, there's our file pointer, here's our format specifiers, and then here are the variables that we want to use, the values that we want to print. Okay, the format specifier, this has to be in the exact order that you want it to show up in the file. Okay, so if you want to print this value and put a space in between it, you need to add a space here. If you want a new line at the end of each record, you need to print off a new line or send a new line character to that file on that file stream. Okay, and you do need that. If I didn't print the new line, then it would just continue to send the same data, write the same data to that very first line. Okay, so fprintf prints to the stream, and now we just repeat the same process we did up above the loop in order to capture more input. So print the question mark, Again, that's completely optional, but that's just to indicate that the user ready to accept input. There's our scanf. Did the user, once we capture those values in scanf, we check standard in. Did the user send in and end a file? If not, great. Another iteration. We print again. Print the question mark scanf. Okay. After we're done with this loop, after the user types Control D to send the end a file, then we break the loop and we do our fclose. Okay. And what I got a little bit ahead of myself in just earlier was that when we're writing to a file, what you'll probably see when you're running, and we'll take a look at this, is that even though you've called fprintf, if you open the contents of your file, you won't see any data there. And that is because we haven't called fclose. This gets stored oftentimes into a buffer, and it just sits there for a while until the system is ready to write it. I don't know exactly why that is, but fclose forces it to flush all the buffers. And that means that it forces it to write to this stream when you say close. Okay, so sometimes if you have printf and you don't see any contents in the file, it's just because it's in a buffer, it just hasn't been written yet. And fclose will make sure you do that. So it flushes the buffer, and at the same time it closes that stream. So you can't use this to force it to write unless you're actually done with that stream. If you use fclose, flushes the buffers, closes the stream, and you want to write again, then you have to open it up again. And that would be this process that we're doing up here. All right, so I'm going to save that. And we'll go ahead and we'll take a look at a quick run through of it. So GCC file IO writing. Okay, it works. Students v2.dat. Okay, just to show that is an empty file. And let's run that program. All right, so there's those couple of puts that I have. This is the format I'm expecting. This is telling me how to terminate the program, and then you can see the question mark just prompting me, telling me it's just a visual reminder or a visual indication that I'm ready to accept input. So if I type in the name, the major, and the student ID, hit enter. Okay, it worked. There were no errors, and now we have another question mark. So that means the program is ready to accept more input. If we go back and look at this file, you'll see there's nothing here. If we look at the program, because we went through one iteration of this loop, we know we called fprintf, because we're back to a printf and a scanf, right? Where program execution is now paused in the scanf as it's waiting for us to type something into standard in. So that's what I was talking about earlier, that even though you've entered it in, even though your program you know for a fact is called fprintf function, it hasn't actually written to that file yet. So, and it won't do that here until we end the program and flush those buffers. So let's type another one in. Okay, so at this point, I should have 2 records in the file. There's still nothing there. So, Control D, and that terminates the program. Okay, so we know we broke the loop, we called fclose, and now when we look at this file, you can see that the content was written. Right, so there's the 2 lines that I've entered in. Or the 2 records, sorry. All right. So that's pretty much it for writing. Again, the biggest catches that you'll run into are opening in the right mode, and then making sure that after your fprintf calls that you close that stream. As far as the lab goes, there's plenty of different ways that you can run that lab. And you can make the lab that deals with reading and writing from files. You can make that work. One way that I would recommend, just if all else fails, if you can't, because once you've opened a stream, I don't know of a way offhand to change the mode that it's in. So if you open it in read only, then you can't change it to an append mode without closing it and opening it up again. You can run the program, and you can run it completely in, you can open up the file right away in append mode, write append, and just run the program that entire way in that mode, and that's fine. Again, talking about something we covered in the earlier lecture, I usually run the program in the most restrictive, and I only change permissions when I have to. So, in my solution for that program, when they select the menu option to write the contents to the file, then I actually close the stream, reopen the stream in the right append mode, write to the file, close it, and then open it up again in the normal read-only mode. Okay, so that's just a suggestion. That's not saying that you have to do that. If you can find a way to make everything work, that's great. I mean, that's the whole purpose of the lab. But if all else fails, That way I know will work for sure, and that might help, save some headache. With the lab itself as well, reading from the file, the first two menu options are pretty much identical. You just have to change the condition, change the if statement for the records that you're looking for to only print the right one. So really, for the lab, all you have to do is be able to take these concepts from this program and from this and apply them in a slightly different situation. Let's see, one last thing. 20 minutes. I still talked a lot. It's only take me a second here. But one last thing I wanted to show everybody. So if you're good to go, you don't have any questions. All I want to talk about for 1 second is using pointers inside of a struct, just in case you got caught up on this. If you're good to go, then don't worry about that. You don't have to watch these last couple minutes. But every once in a while, someone will run into an issue using this. Let's see, what do I call this? It's called string in a structure. And where this can be kind of tricky is if you want to use this member in a scanf. And so I'm just going to wedge some code in here that has absolutely nothing to do with this program. So we have our A student, and let's say that we have that string member. And so if I do something like this, it'll actually work, right? Because we're assigning to that member, it's a char pointer, and we're assigning to it a string literal. And C will take that, and it'll find memory for it, and it'll work fine. But now if all of a sudden we wanted to use that in a scanf, and I wanted to say a student dot string then this won't work. And let's try to compile that real quick and see. Okay, segmentation fault. So I compiled that program and ran it. And when we got to this line right here, that's where the program execution paused, and it was waiting for me to type something in. And it crashed, right? Because what happens is, with this, this is kind of a special case with char pointers, and that is that when we assign it a string literal, C puts it in a special place in memory. It's typically read-only. We can't iterate over it. It's not an array. We don't know where the memory is. It handles all that for us. But in this case, this char pointer doesn't actually have any memory allocated to it yet. And so in order to make something like this work, what we have to do is we have to malloc memory for that string. So we have to say student.string equals malloc, let's see, char times, let's just say 50. Okay, so size of char is 1 byte, 50 bytes, so that'll be basically a string of size 50. But now, because that's a pointer that has memory allocated for it, it's pointing to that memory address. And so now it knows when you try to do an assignment like this, it has a place to put that string. So if we do a puts and we print off the value, what you'll see is we'll capture it and then we'll print it all in one go. So we'll go back, we'll compile that, and we'll run it. Let's see, and now it works. Okay, so kind of weird. If you ran into that, if all else fails, oftentimes you can just use char arrays, but that is how you work around using that member as a char pointer inside of a structure. Okay, so any questions? Please let me know. Send me an email. Be more than happy to help you out, point you in the right direction. Otherwise, hope everything is going well, and talk to you in the next lecture.